Hey students, before you get this video started, make sure your math notebook is open in front of you. You're going to take these notes on the right-hand side, and you'll use the left-hand side for Edpuzzle questions, entry tasks, or any other notes you take during our class time together. So the name of our section today is 7.5, Writing and Graphing Inequalities. So inequalities are things that don't have equal signs but have other symbols like a greater than symbol or less than symbol. Our learning target is I can write and graph inequalities. So the first thing we're going to do is define what is an inequality. An inequality is a mathematical sentence that compares expressions. What that means is we have two expressions, two things that might have variables, numbers, operations, and we are comparing them using one of the symbols that you see in the chart here. This chart will be available to you on Google Classroom, so you don't need to copy it down if you don't want to. We have four symbols. The first two are ones you've seen before. The symbol right here, this one, means less than. So the thing on the left is less than the thing on the right. This next one just means greater than. The thing over here on the left is greater than the thing on the right. The next two are a little bit new to us. So they look like the greater than, less than symbols, but they have a line underneath. Adding that line underneath adds the words or equal to. So this symbol means less than or equal to. It means the thing on the left can either be less than the thing on the right, or it can be equal to it. It can be either or. So then this one means greater than or equal to. It means the thing on the left can be greater than the thing on the right, or could be equal to it. Either of those would be fine. So the first couple things we're going to do is writing inequalities. So it's going to be just like writing equations. We have a phrase, and then we're going to turn it into something using numbers, variables, symbols, etc. So our first one says a number C is less than -4. All right, so a number C, that just means the variable C. Then we see the words less than. If I go up into my chart, I see that this guy right here, that one means less than. So I'm going to go ahead and put a less than symbol, -4. And that is it. Example 2, 4 times a number Q is at most 16. So we see 4 times a number Q. Remember, times means multiplication. So 4 times Q, or just 4Q. Then we see the words at most. So let's go up into our chart. Right here, I see is at most. So we're going to go ahead and use the less than or equal to sign. Is at most 16. And there we go. All we did is replace these words with different numbers, variables, and symbols. The next thing I want to talk about is the solution of an inequality. So we've talked about solutions of an equation. Those are values that make the equation true. The same is true of solutions of an inequality. A solution of an inequality is just a value that makes the inequality true. It means if we plugged in that value for our variable, our inequality would be true. We actually have one word that goes along with that, one term, and that is the term solution set. A solution set is the set of all solutions of an inequality. You might be thinking that's kind of weird because when we solved equations, there's only one value that makes our equation true. Well, with inequalities, there can be many. Let me show you an example. Let's say we had x is less than or equal to 10. That means that x can be any value that is less than 10 or is equal to 10. So there are tons of different numbers that would work. X could be 1 because, yes, 1 is less than or equal to 10. X could be 5 because, yes, again, 5 is still less than or equal to 10. X could be 10 because 10 is less than or equal to 10. So we can see that there are multiple values that make our equation true. So let's talk about checking a solution. Let's check if 3, 4, and 5 are solutions to x plus 3 is less than or equal to 7. So we're going to plug in 3, 4, and 5 for x. We're going to do three separate things and determine if each of these are a solution or not, if they belong to the solution set. So here's our first one, 3. So we put a 3 where x goes. 3 plus 3 is less than or equal to 10. Sorry, 7. 3 plus 3 is 6. Is 6 less than or equal to 7? Yes, it is. 6 is less than 7. That means it works out. 3 is a solution. What about 4? Let's put a 4 where x goes and see if that works. 4 plus 3 is 7. Is 7 less than or equal to 7? Well, 7 is equal to 7, so yes, it does work out. We are good. Remember, less than or equal to means it could be either. So if it's less than, it's good, or if it's equal to it, it's good. All right, last one. Let's plug in 5 for x. 5 plus 3 is 8. Is 8 less than or equal to 7? No, 8 is actually greater than 7, so this one is not a solution. So 3 worked, 4 worked, but not 5. Okay, the last thing we're going to talk about today is the graph of an inequality. The graph of an inequality shows all solutions of an inequality. So we use a number line to show all of the numbers over here are solutions to this inequality. There's a couple things we need to know about the graphs of an inequality. If we use a dot, we call this actually a closed circle. It means the number is a solution. So what I mean by that is if we put a closed circle on a number, we are saying, yes, this number would make our inequality true. If we use a circle like that, we call that one an open circle. It means the number is not a solution. So maybe we say, oh yeah, all the numbers less than 5 are going to work, but not 5. We would put an open circle on 5 because 5 isn't a solution. And then the last thing we want to know is that an arrow shows where the solutions fall. Okay, I know that all of this stuff probably is like, what the heck? I don't know what that means. Let's do an example so that I can explain what each of these things means in context. So here we go. Our inequality is g is greater than or equal to 2. So I want to graph this. I want to show all the values that are greater than or equal to 2. So I'm going to draw a number line here. Let's just put 0 there. 1, 2, 3, 4, 5, 6. All right, so first I say, okay, my numbers have to be greater than or equal to 2. So if it could be equal to 2, we're going to go ahead and put a closed circle. We're saying, okay, 2 would work. Our number could be equal to 2. Now we need to decide which way the arrow is going. Are the solutions this direction or are they this direction? Well, it says that G can be greater than or equal to 2. So we should draw the arrow in the direction that is greater than 2, which is this way. What I like to do is I like to do this little squiggly line to show that I'm shading it this direction, and I put an arrow on the end. I'm saying, look at that. Every number that is 2 or bigger would satisfy this inequality, would make it true. Okay, let's do another one. This time we have A is less than 4. So I'm going to draw my number line. Let's go 0, 1, 2, 3, 4. Okay, so we're saying that A has to be less than 4. So could it be the number 4? No, 4 is not less than 4. So we're going to put an open circle there. We're saying 4 doesn't work, but everything less than 4 does work. So which direction are the numbers that are less than 4? Well, that is to the left. So we are going to shade to the left and put our arrow to say, look at that. Everything that is not 4 but below 4 would make our inequality true. Number 6, we have 5 is greater than or equal to x. Okay, so this one, actually, before I do this one, I'm going to flip it around because I want my variable to come first, right? In the first two, the variable came first, so let's flip it around. So if I put x here, we still want the 5 to be the one the alligator's eating, so we're going to just flip the symbol as well. So now it says x is less than or equal to 5. So that means I need to figure out if I'm using an open or closed circle and figure out which way I'm shading. So let's go 0, 1, 2, 3, 4, 5, 6. All right, it says x is less than or equal to 5. So that means that 5 would work. X could equal 5, so we're going to go ahead and put a closed circle. We're saying, yes, 5 does work. Now we're going to say, okay, where are the numbers that are less than 5? Well, that is to the left, so we are going to shade that direction. Put an arrow. We're saying x can be anything that is 5 or lower. You'll actually notice that if we make it so that our inequality has the variable first, the symbol points in the direction that our arrow should be going. So in our first one, this little inequality symbol points to the right, so our arrow is to the right. In the next one, it points to the left, so our arrow is to the left. In this one, once we flipped it to have our variable first, again, it pointed to the left, our arrow is to the left. So if you just rewrite it so that your variable is first, this is going to show you the direction you should be putting your arrow. Okay, last one. 6 is less than y. Again, if we just flip this around, we put the variable first, it'll be easy to tell which way we should shade, which way our arrow should go. So let's flip this around and make it y is greater than 6. Let's draw our number line. Let's go 0, 2, 4, 6, 8, 10. So the number 6. Is 6 greater than 6? No, it is not. So 6 is not a solution, so we're just going to put an open circle there. We're saying 6 doesn't work, just everything that is greater than 6. Everything that is greater than 6 is this direction. And again, because our variable is first, we can see that our inequality symbol is also pointing that way. So all our solutions are everything that is above 6.